Hi, today we're going over section 1.6, which is exponent laws and order of operations. When evaluating mathematical expressions, we use order of operations, commonly referred to as BEDMAS, which tells us what order to do things in. So first thing we want to do is anything in brackets that we can. Next, we would want to do any exponents. After that, we have division and multiplication. And we do them in the order they appear. Last, we have addition and subtraction. Also occurring in the order they appear. So we're going to use BEDMAS to help us solve and simplify some questions. So first one, we've got 2.5 to the power of 3 times 2.5 to negative 5 to the power of 2. Now we've got two exponents of the same base being multiplied together inside our bracket. So we want to do that first. Because they're multiplying together, that means we add our exponents. So this becomes 2.5 to the power of 3 minus 5 squared. So that would give us 2.5 to the power of negative 2 to the power of 2. We'll do our exponent next. So we have 2.5 to the power of negative 4. I'll rewrite this as a fraction. 2.5 is the same as 5 over 2. That's to negative 4. Next step is to flip this because we have the negative. So we have 2 over 5 to the power of 4. Now, 2 to the power of 4 gives us 16. And then 5 to the power of 4 gives us 625. Next one we have is here. We'll do our exponents first, then we can multiply these together. So that gives us 5 over 6 to the power of 2 times 7 times 5 over 6 to the power of 3 times negative 4. So that's 5 over 6 to the 14 times 5 over 6 to the negative 12. So that's 5 over 6 to 14 minus 12. So 5 over 6 squared. 5 squared is 25. 6 squared is 36. On to the next one. We deal with our exponent first, so 4 stays in front. We flip 3 over 5, so it becomes 5 over 3. Becomes cubed, so we have 4 times 5 cubed is 125. 3 cubed is 27. 4 times 125 is 500 over 27. Example, write each expression as a single power, then evaluate, write each answer as a fraction or whole number. So this is 7 over 8 here. I know it's hard to read. This is 1 over 6. We'll start with this one down here. So we have 36 to the 7 over 8 divided by 36. We want these of the same base, so we can actually add them. So I'd multiply top and bottom of this one by 4. So we have 4 over 6 plus, 4 over 24 plus 11 over 24. That's all being squared. So that's 36 to 7 over 8 over 36 to the 15 over 24. And that's being squared. Now, because we're dividing, that's the same as subtracting this fraction. So we'd have 36. We want the same base, so I'd multiply the top and bottom of this one by 3 to get 24. So I have 21 over 24 minus 15 over 24, and then that's being squared. Continuing this up here, that gives us 36. 21 minus 15 is 6. So 6 over 24 squared. We can simplify this. Both are divisible by 6. So that gives us 36 to 1/4 squared. So that's the same as 36 to 1 over 4 times 2. So that's 36 to the 1/2. So that's 6. Next one, we've got 8 to 2/3 minus 9 to negative 1/2. So what we'll do is simplify these as much as we can right off the start. So this is the same as a cube root of 8 squared minus the square root of 1 over 9, and that's squared. So cube root of 8 is 2, squaring it gives us 4. So we've got 4 minus square root of 1 over 9 is 1/3 squared. 4 minus 1/3 is 11 over 3. That's being squared, so that gives us 121 over 9. Continuing on, we have 5 to the power 1/3 times 3 to negative half to the power of 6. So first thing I would do is apply this exponent to both of these inside. So that gives me 5 to the 1/3 times 6 times 3 to negative 1/2 times 6. 6 times 1/3 is 2, so we've got 5 squared times 6 times negative 1/2 would be negative 3. We've got 25 times 1 over 27. So that gives us 25 over 27. Next one, we have 2 to the power of 9 over 5. So that's a 5th root of 2 to the power of 9 times the 5th root of 64. So the 5th root of 2 to the power of 9, we can't really do and get a decimal, so we're actually going to take a different step with this. We're going to go back to our initial point and try to get the same base for both of these. So we have 2 to the power of 9 over 5. 64 is 2 to the power of 6. So we have 2 to the power of 6 to 1/5. So that gives us 2 to 9 over 5 times 2 to 6 over 5. So that's 2 to 9 over 5 plus 6 over 5. So that's 2 to 15 over 5, which is 2 to the power of 3 or 8. Next example, simplify each expression, write each expression with positive exponents. So for this, we just multiply like terms together. So we've got 2 times 6 is 12, times 5 is 60. X to negative 4 times x to 3. So we have negative 4 plus 3 would be x to negative 1. Y cubed times y to 5 would be y to the 8. Now, it states with positive exponents. If something's a negative exponent, it moves to our denominator. So we've got 60 y to the 8 over x. This one, we can divide or simplify like terms. So actually first we'll apply the exponent here. So we have 9x x2 to the power 2 would be 4, y to negative 10 over 18 x to 6 y to negative 7. Reducing these to lower terms, we end up with a 2 on the bottom. X to 4 over x to 6 would give us x squared on the bottom. And this would give us y cubed on the bottom. So we have 1 over x squared y cubed. Next one, this one, we have 2 separate terms in each bracket, so we're going to have to FOIL it out. So we have this times this, so that's going to give us 18x squared. Then we have this times this, so we have minus 12xy squared. Then we have this times this, so plus 15xy squared. And then this times this, so minus 10 y to a 4. Combine like terms, we have 18x squared plus 3xy squared minus 10y to the 4. Now practice for this section can be found on page 69, numbers 3 to 7, 9, 11, 14, and 21.